Okay, so now we'll talk about electrolytic cells. So what electrolysis is a process where electricity is used to make a chemical change happen. Reaction change. That wouldn't happen spontaneously. Spontaneously on its own. So let's suppose that we see the table salt. So usually what the electrolytic cells and electrolysis is breaking down the compound. If we have table salt in our home, then we see that table salt will stay as a table salt forever, will not be decomposed into sodium ion and chloride. Okay, so what do we want? What do we want to do through electrolysis or through electrolytic cells is to break this down. So we want to have now, instead of sodium chloride, we want to have sodium and sorry about my dog. And what we are aiming in terms of the chemical reaction here is to see a reduction and an oxidation reaction. So in order to identify this, we will see what is happening with oxidation number. Is it changing or not? Sodium has an oxidation number of +1. I will write them in red, so as always. And chlorine will be -1 because the compound on its own should be 0, and sodium is 0 because it is an atom, and chlorine is 0 as well. So what we see here is that an oxidation and reduction is happening, because in one side we see that sodium is becoming an 0, and then from +1 into 0, and chlorine is becoming from -1 into 0. So what we see for sodium is that we see that is gaining electron, and what we see for chloride is losing electron. Okay, so when gain and loss is happening, oil-rich, remember what we have said, then oxidation and reaction is happening. So if we write the half oxidation and reactions, half reactions, then we will have for sodium from an +1 will gain an electron, so will be +1 electron, and will be an A0, so it is gaining electron, which means that what is happening is a reduction, or this is becoming oxidation agent. So what is happening on the other hand with chlorine, it is losing an electron, becoming chlorine 0, and one electron is in the product because it is a losing electron, which means that is oxidized. Okay. However, when we see those reactions, those are half reaction, oxidation and reduction reactions. They do not happen. They do not happen, any of them, on its own. You can see even from the table on your data booklet on page 7 that this is not happening in its own, and in chemistry what do we say that this is a non-spontaneous reaction. Okay, so therefore to make this happen, what do? Is we force this process to happen. And how do we force this? Through battery. So batteries are with two poles, positive and negative poles. And what is happening with the positive pole, I will just use a different color. With a positive pole is pulling the electrons, pulls electrons to the battery, and with the negative pole of the battery is pushing the electrons to the element. Now the pull of the electron is happening. So pull of the electron is, in our case, is happening to chloride. So in our case will be pull the electrons from chloride, and what it is, we have to make it in red color so that we save the same. It pulls electrons from chloride, and what is pushing, where is it pushing the electrons towards to, is sodium plus, okay, sodium ion. In this case, what is happening to the chloride is oxidizing, and what is happening to sodium ion is reduced. Reduction. Okay, so let's take a closer look as to how this process is happening. So let's suppose that you have a battery here where you can see as a positive and negative, and sometimes the battery is represented like this, where the long line represents the positive and the short line represent the negative. Okay, so, and then connected with this battery, there are two electrodes that are into the, not solution, but the material. So those are two electrodes. And they are very close to each other. But then inside this, in a big beaker, what do we have in our case is a molten, so NaCl, but it is melted. And when NaCl is melted, what we see is we see an A plus and Cl minus. So Cl minus. They are kind of together, but just for the sake of explanation, I'm doing it like this. So the electrode that is connected with the positive pole of the battery is known as the anode, and the electrode that is connected with the negative pole is known as the cathode. Why it is like this? Because what is happening in the anode is pulling the electrons. So anode is pulling electrons, which will result into oxidation. And wherever the oxidation is happening, we call it anode, anox. Remember the acronym that we were using? And what is happening in the cathode is that the electrons are pushed toward, and what is happening is reduction. And remember what we said, cut red for cathode. So when the reduction is happening, we call it cathode. Now we see and we know that the electrons are pulled by the positive pole and are pushed by the negative pole of the battery. So now, since the electrons are pushed into the negative pole, so then the electrons are coming to the electrodes. Those are known as the electrodes. And then as they are here, then they are looking for an Na plus, because this is a negatively charged, and negative charge will attract a positive one. Okay? If we use a different color, then probably will make more sense. So this negative charge will be attracted to the positive charge, so then the sodium ion will go toward the cathode. Okay, same thing will happen with this other one here. While what is happening as the electrons are pushed away, or are pulled away from the positive pole, then what is happening, those chlorides are attracted to the anode, and then they are grabbing the electrolyte electrodes are grabbing that extra electron that chloride has, and as soon as we see two chlorine atoms, they are combined together into Cl2, because chlorine is a diatonic element, molecule. So then those electrons are moving, and this is what is happening with the electrolyte cell. Now, a question may be as to what is the minimum battery potential difference of the battery that will make this possible. And again, what we will use is the fact that the electric potential of the cell is whatever is the electric potential of cathode minus the electric potential of anode. And you will see that in the electrolyte cell, when you're using pages or information on pages 7, will be a negative value. So if you have, let's suppose, lead, CO2 plus aqueous and Cl minus aqueous solution. Then you will see that what is happening in the cathode is that cobalt 2 plus in aqueous solution will grab 2 electrons and will become a cobalt solid. And what is happening in the anode is that is giving 2 electrons, so Pb2 plus 2 electrons in aqueous solution. This is in aqueous solution. Then as the net reaction, we will see that we have 2 electrons are cancelled out, so CO2 plus Pb solid aqueous will be CO solid plus Pb2 plus in aqueous solution. And when you take the difference between the two, or if you draw the battery, the electrolytic cell, including the power, then you will have something like this. Positive is here, negative is here, and then you will have the electrolyte, electrodes. Electrodes are here, and then you will have Pb solid and a Pb solid, and the electrons will flow in this direction and will be pushed by the negative pole. This will be anode, and this will be cathode, and we will have the CO2 plus in aqueous solution will go towards the cathode, and Cl aqueous solution will go towards the anode. And when you calculate the electric potential of the cell, you will go whatever is the electric potential of cathode minus the electric potential of anode. And using the information on page 7, you will find that it is negative 0.28 volts for cathode minus negative 0.13 volts for anode, which gives you a number of negative 0.15 volts. This is another indication that this is an electrolytic cell, because the battery is needed to make the reaction happen, and it's a minimum of 0.15 volts that the battery should have to make this possible. Okay, this conclude the cells, and we have one more topic to discuss into the electrochemistry, which is Faraday's law and cell stoichiometry, and then we are done with electrochemistry.